German steel meant to help stop the Allied invasion on the Normandy beaches ended up welded to American Sherman hulls, helping those same tanks cut through the French countryside inland. That reversal is small enough to miss in the scale of D-Day, but it explains something much larger about the campaign. Germany had spent years building obstacles, bunkers, minefields, gun positions, and defensive plans intended to make an invasion prohibitively expensive. The Allies arrived with an enormous material advantage, but material alone did not guarantee movement. 6 weeks after the landings, American armor was still being trapped by ancient hedgerows that no bomber factory, battleship, or landing craft could simply erase. The solution that began to unlock that terrain came from Sergeant Curtis Culin, who used steel, salvaged from German beach obstacles, to create cutting prongs for tanks. The weapon that had failed to stop the invasion was repurposed into a tool for continuing it. That detail matters because the Normandy campaign was not a simple story of one side having more tanks, ships, aircraft, and ammunition. Germany could still kill Allied soldiers in large numbers. German units could still use terrain brilliantly. German anti-tank teams, machine gunners, artillerymen, and armored units could still make individual fields, villages, and road junctions extraordinarily expensive to take. What the Allies possessed was something harder to reduce to a single number. They could produce on a massive scale, move that production across an ocean, replace losses, sustain fire, improvise when a plan failed, and then spread a useful battlefield idea quickly enough for it to matter. The Normandy campaign became a contest not merely between weapons, but between systems for turning resources into combat power. That contest had already appeared on June 6. Allied records in the account put the invasion force at 6,939 vessels, including 1,213 naval combat ships and more than 4,000 landing ships and landing craft. Allied aircraft flew 14,674 sorties on D-Day. Estimates for serviceable German aircraft in western France vary, but the imbalance was still immense. At the same time, roughly 166,000 to 160,000 Allied troops came ashore in Normandy. German fire inflicted devastating losses, and for hours, the assault there was in serious danger. Small groups of American troops, engineers, junior officers, and sergeants, eventually worked their way off the beach, while naval destroyers moved close to shore to support them. The German problem was that inflicting losses was not the same as stopping the system that was producing and replacing the men and equipment coming at them. At WN-62, Heinrich Severloh later recalled firing 13,500 rounds from his position over about 9 hours. His later claims about the number of casualties he personally caused remain unverified, but the ammunition figure captures the scale of the defensive effort. German positions began reporting shortages, while the Allied flow continued. Some German defensive calculations had been built around a more limited assault. Positions that expected to hold ammunition for days could burn through stocks in hours. Roads used to move reserves and supplies were under pressure from Allied air attack. The defender could fight hard and still be losing the larger arithmetic. That arithmetic was visible in the sky. A German armored reserve was valuable only if it could reach the place where it was needed. Artillery mattered only if ammunition could get forward. Reinforcements mattered only if roads and rail lines remained usable. Field Marshal Gerd von Rundstedt's June assessment emphasized that Allied air power had made movement by day extraordinarily dangerous. He cited 29,000 Allied sorties in roughly 2.5 days and described fighter bombers attacking movement far beyond the beachhead. His conclusion was operational, not rhetorical. German doctrine could not function normally when tanks, trucks, supplies, and replacements could not move freely. That is why the argument over where to keep German armor before the invasion had limits that become clearer in hindsight. Rommel favored positioning armored forces close enough to strike the beaches quickly, Rundstedt preferred retaining a larger reserve for a counterattack once the invasion point was confirmed. Both understood that the invasion had to be contained before the Allies established a secure foothold and broke into France. Yet the more fundamental constraint was freedom of movement. Even a perfectly positioned formation could not ignore Allied aircraft and naval gunfire. Even the right order could arrive too late if communications were broken, command was divided, or the roads themselves had become killing grounds. The weather added another layer. German forecasts judged the conditions poor for a major invasion. Rommel left France before June 6th, and other officers reduced their readiness because they believed the weather gave them time. Allied meteorologists identified a brief usable window, and Eisenhower chose to go. German intelligence also received warning indicators, but the chain of command did not convert all of that information into effective action. Airborne landings then added confusion behind the beaches. Some reports were real, some were scattered, and some Allied deception measures contributed to uncertainty. German commanders were not simply facing a large attack. They were facing an operation designed to overload the ability to identify the main threat, move reserves, and respond in sequence. Within hours, the defensive problem had changed from stopping landing craft to surviving a growing Allied lodgment. The most important thing about D-Day was not that every German strongpoint collapsed or every Allied plan worked. Many did not. The important thing was that enough of the Allied system survived the first shock to keep expanding. Once troops, vehicles, ammunition, engineering equipment, and fuel were crossing the beaches continuously, the invasion stopped being a single assault that Germany might defeat in one violent morning. It became a logistical process. If you like WW2 stories that explain the mechanism behind the headline, subscribe, because Normandy is full of details like this. The scale behind that process had been building for years, and Nazi leadership had repeatedly underestimated it. Part of that failure came from ideological assumptions about the United States. Hitler and other senior Nazis portrayed American society as divided, decadent, racially mixed, and therefore incapable of sustaining total war. Those claims were not simply insults for public consumption. They also shaped the worldview through which German leaders judged American military potential. That distinction matters. Propaganda is dangerous enough when it misleads a population. It becomes strategically lethal when the people making decisions begin using it as intelligence. The first encounters with American forces could even reinforce the mistake. At Kasserine Pass in 1943, American troops suffered a serious defeat and heavy equipment losses. German propaganda treated the result as confirmation that American soldiers lacked the experience and fighting ability to face veteran Axis troops. Rommel, however, also recognized a different pattern. The Americans had recovered quickly, regrouped, and shown an ability to learn. Within months, Axis forces in North Africa were gone. The lesson was that a temporary American weakness could be temporary, while the industrial and organizational system behind it kept feeding new men, equipment, and lessons into the fight. Production figures make that transformation easier to understand. American production figures in these wartime accounts reached 29,497 tanks in 1943, while aircraft output is given as 84,853 in 1943 and 96,270 in 1944. Willow Run is described producing a B-24 at peak pace roughly every 63 minutes. Liberty ship construction fell from periods measured in many months to regular production cycles of roughly a month or a little more, with the United States launching several Liberty ships a day at peak output. American industry was not producing one miracle weapon. It was producing a complete military ecosystem. That ecosystem is what arrived off Normandy. The bombers mattered because they attacked German transportation and air power before the invasion. The fighters mattered because they restricted German movement after the invasion. The landing craft mattered because they delivered soldiers and vehicles. The merchant ships mattered because they carried the continuing tonnage behind them. Trucks mattered because supplies had to leave the beaches and follow the army. Artillery mattered because its ammunition supply allowed it to fire at a tempo Germany increasingly struggled to match. It was one node in a chain of fuel, spare parts, recovery vehicles, mechanics, ammunition, drivers, radios, road networks, depots, shipping, and factories. That is also why arguments that focus only on the quality of one German tank against one American tank miss the operational question. A Tiger could be formidable. German anti-tank weapons could be lethal. Experienced German crews could win local engagements. Michael Wittmann's success at Villers Bocage provides one example of a German armored commander inflicting severe local losses. But a tactical success did not solve Germany's replacement problem. A damaged or destroyed German heavy tank was difficult to replace. Allied losses entered a system designed to restore combat strength quickly. The campaign was not decided by asking which tank was best in a duel. It was decided by asking which army could keep useful armored formations operating day after day while moving fuel, ammunition, replacements, and repair capacity forward. The same difference appeared when German reinforcements tried to reach Normandy. German formations could take far longer than planned to reach Normandy, with roads, railways, and bridges under persistent attack. The 2nd SS Panzer Division Das Reich took 17 days to reach Normandy from southern France and suffered significant vehicle losses on the way. A reserve that arrives late is not the same military asset as a reserve already in place. A tank that breaks down or is hit on a road cannot contribute to a counterattack. A replacement division delayed for days gives the enemy more time to strengthen the front. Meanwhile, Allied strength in the lodgement kept growing. By the end of June, roughly 850,000 Allied troops, 570,000 tons of supplies, and 150,000 vehicles had crossed the Channel. That is the operational meaning of industrial superiority. Factories by themselves do not capture ground. But production, connected to shipping, ports, beach organization, engineering, transportation, and command, can turn a temporary foothold into a permanent military presence. Germany needed the invasion to remain fragile. The Allied system made it less fragile with every passing day. And then Normandy produced a problem that should have favored Germany even more than any bunker had. The bocage was not a purpose-built German fortification. It was a landscape of small Norman fields divided by thick hedgerows, growing from raised earth banks, often reinforced by deep root systems and mature vegetation. On a map or aerial photograph, it could look like agricultural texture. At ground level, it broke the battlefield into compartments. A tank approaching a hedgerow often could not simply drive through. If it tried to climb the bank, the vehicle could tilt upward, exposing its thinner underside and losing the ability to bring its gun effectively onto targets ahead. If infantry crossed first, defenders could fire from concealed positions. If engineers used explosives, the breach took time and announced where the next vehicle would appear. The terrain did something remarkable. It reduced the value of several Allied advantages at once. Long-range observation became harder. Tank movement was channeled. Air power could not solve every small defensive position hidden beneath trees and banks. Artillery could suppress areas, but a hedgerow network created new protected positions, field after field. Roads and gateways became predictable. German defenders could cover those approaches with anti-tank guns, machine guns, mines, and infantry weapons. An army that had crossed the English Channel with thousands of ships now found itself fighting for individual enclosed fields. It threatened the logic of the Allied plan. The invasion had been designed to break out into mobile warfare. British and Canadian forces were supposed to push around Caen, while American forces expanded through the Cotentin Peninsula, took Cherbourg, and drove south. Instead, the American advance became a grinding fight, measured in short distances. The Allies had excellent aerial photography before D-Day, and the hedgerow pattern was visible. The failure was not an absence of information. It was a failure to translate what was visible into what it would mean for tanks, infantry, and combined arms once they moved inland. Intelligence can be technically correct and still be operationally inadequate. A photograph can show thousands of field boundaries. A planner can count them. But unless someone asks how a Sherman crosses one under fire, the information has not yet become a solution. Normandy exposed that gap brutally. The Allies had spent enormous effort preparing for beach obstacles, minefields, coastal guns, amphibious timing, landing craft control, and airborne operations. Then they encountered an inland obstacle that had existed for generations and discovered that they had no standard doctrine or dedicated equipment for it. This is the point where the story of Allied superiority becomes more complicated. If industrial power alone decided everything, the bocage should not have stopped the Americans for weeks. They had more vehicles, more aircraft, more artillery, and more supplies. Yet German defenders were still able to exploit the terrain so effectively that those advantages were partially neutralized. The problem was no longer whether the United States could build enough tanks, it was whether those tanks could cross the next 50 feet of earth without exposing their bellies to fire. American units tried multiple answers. Bulldozers could force breaches, but they were limited in number and vulnerable. Explosives could cut openings, but the preparation was slow and could reveal the intended passage. Tanks could attempt to climb the banks, but that created exactly the exposure defenders wanted. Tactical teams learned to combine infantry, armor, engineers, and artillery more carefully, but the mobility problem remained. A battlefield system with extraordinary global reach had been reduced to searching for a mechanical answer to a wall of dirt and roots. Curtis Culin's contribution emerged from that environment. Culin was a 29-year-old sergeant from New Jersey. The core idea was simple. Instead of trying to climb over the bank or blast a large opening, give the tank steel teeth that would bite into the base of the hedgerow. The tank's own weight and engine power would force the prongs through compacted earth and roots while keeping the hull relatively level. The prongs had to be strong enough, mounted low enough, and angled so they cut rather than ride upward. The steel was available because the Germans had already supplied it. Czech hedgehog obstacles had been placed on the invasion beaches before D-Day. Built from heavy structural steel beams, they were meant to damage landing craft, obstruct movement, and support other beach defenses. Once the landings succeeded, many of those obstacles were destroyed, bypassed, or pushed aside. Their beams could be salvaged. Culin and the men working with him could cut and weld that steel onto a tank. The Atlantic Wall had become a parts bin. A prototype used 4 steel prongs attached to the front of a Sherman. The first July tests succeeded, with the modified tank driving into representative hedgerows without having to climb over the top. Further trials followed under different conditions. The important point is not the exact number of seconds in every test. It is that the device repeatedly converted an obstacle that had dictated tank movement into something a tank could attack directly. That changed the tactical geometry. Before the cutter, defenders could focus on known gates, roads, and prepared breaches. Those were the places where American armor had to appear. After a cutter worked reliably, the hedge itself could become an approach route. The modified tank did not need to search for the passage the Germans expected it to use. It could create a new one. A simple attachment, therefore, did something more important than save time. It multiplied the number of possible directions from which American armor could move. The next step was organizational. A useful idea in one platoon is not yet an operational capability. Demonstrations moved rapidly up the chain of command until Omar Bradley saw the device on July 14th. Bradley's response was to push for large-scale modification before Operation Cobra. Ordnance and maintenance units were ordered to manufacture and fit cutters to as many vehicles as possible. It is that the idea spread quickly enough for a substantial number of armored vehicles to enter the coming offensive with a new way to cross hedgerows. That speed is the real bridge between Curtis Culin's welding torch and Willow Run's assembly lines. The cutter itself was not an industrial masterpiece. It did not require a new engine, a new gun, or a new factory in the United States, but an army with deep maintenance capacity, abundant welding equipment, available steel, flexible supply units, and commanders willing to authorize field modification could take a local improvisation and reproduce it fast. Industrial power provided the reservoir. Organizational flexibility determined whether that reservoir could answer a problem no pre-war production plan had predicted. Which mattered more in Normandy, Allied material superiority, or the speed with which units adapted that material to unexpected problems? Tell me below. This is where Nazi assumptions about American military culture collided with battlefield reality in another form. German propaganda had presented Americans as dependent on comfort and mass-produced goods. Yet the same habits of standardization, mechanical work, repair, automotive experience, and large-scale production could be military strengths. A society skilled at making, maintaining, modifying, and distributing machines had a way to turn a sergeant's workable idea into hundreds of modifications without waiting for a perfect centralized design. None of that means the Rhino cutter alone won Operation Cobra. Cobra was a far larger combined arms effort. The offensive depended on infantry, armor, artillery, engineers, and an enormous aerial bombardment. The opening bombing inflicted catastrophic damage on German positions, but it also caused American casualties, including the death of Lieutenant General Leslie McNair. Allied firepower was overwhelming, but it was not automatically precise, safe, or controllable. Material superiority created options and destructive capacity. It did not remove friction, error, or loss. Operation Cobra began on July 25th. The first phase was not an instant armored race across France. Infantry had to exploit the effects of the bombardment and break through German positions. German units were disorganized and damaged, but resistance remained. Civil Corps Commander J. Lawton Collins accelerated the commitment of armored formations when he judged that the German front was breaking. That decision mattered because a breakthrough has a shelf life. If armor waits too long, defenders can rebuild a line. If it moves too early, tanks can outrun infantry support and drive into intact defenses. Collins chose speed. The modified tanks now mattered in a different context from the July tests. They were no longer demonstrating that a machine could cross one hedgerow. They were helping armored units maintain momentum across many of them. Post-battle analysis credited cutter-equipped tanks with a large share of successful hedgerow breaches during Cobra, though that should be treated as an after-action estimate rather than a universal law. Tank crews could avoid some predictable roads and openings. They could create routes that German anti-tank gunners had not prepared to cover. That is the central belief update in Normandy. On D-Day, Allied scale made the Atlantic Wall permeable. In the bocage, terrain temporarily made Allied scale less useful. With adaptation, that scale became mobile again. The story is not a straight line from more factories to inevitable victory. It is a cycle. Production creates capability. The battlefield exposes a limitation. Soldiers and commanders adapt. Logistics spreads the adaptation, and the resulting capability changes the battlefield again. Once the breakout gained momentum, the German defensive advantages changed rapidly. The bocage had allowed small units to hold narrow compartments and forced the Americans into costly frontal approaches. Open country rewarded the opposite qualities: mobility, fuel, communications, recovery capacity, artillery supply, and the ability to keep armored columns moving. These were precisely the areas where the Allied system was strongest. By July 31st, American forces had reached Avranches, opening routes toward Brittany and deeper into France. On August 1, Patton's Third Army became operational and began exploiting the breach. Germany had demonstrated that it could still impose a tactical stalemate when terrain favored defense. It could not turn that stalemate into strategic recovery. It lacked the protected transportation network, fuel security, aircraft, replacement flow, and reserve mobility needed to restore a broken front once American armor reached more open terrain. Allied aircraft continued to attack movement. Allied artillery could be supplied at high rates. Damaged American vehicles entered a repair system. Fresh formations and supplies continued to cross the channel. The German command understood parts of this before the campaign ended. Rundstedt's June report identified air mastery as a central reason German movement and supply were failing. Rommel had warned before the invasion that Allied air superiority would make large armored movements dangerously difficult. By mid-July, Rommel was warning Hitler that the unequal struggle was approaching a crisis. These judgments did not mean German soldiers stopped fighting effectively. They did not mean every German commander shared the same analysis. They meant that senior officers could see an operational equation their forces had no easy way to reverse. That equation was larger than Normandy. Germany was fighting on multiple fronts while Allied production continued at a scale its own economy could not match. American factories produced aircraft, tanks, trucks, artillery, ammunition, and ships in enormous numbers. British industry and the resources of the wider Allied coalition added still more capacity. The Soviet Union was exerting immense pressure in the East. A German tactical success in France, therefore, had to achieve more than a local victory. It had to buy time, preserve forces, and somehow change a strategic balance that was worsening simultaneously in several directions. A sophisticated weapon is useful only when there is fuel to move it, ammunition to fire it, trained crews to operate it, spare parts to repair it, transport to deliver it, and time to replace it. Normandy punished every break in that chain. Allied air power attacked transportation. Naval gunfire reached inland areas near the coast. The front consumed ammunition quickly. Vehicles broke down. Roads were crowded and dangerous. Communication lines were disrupted. The German army could still field impressive weapons, but the system supporting them was increasingly brittle. The bocage exposed it. The friendly fire tragedy during Cobra exposed it. The initial disaster at Omaha exposed it. Kasserine had exposed it earlier. The difference was not an absence of failure, it was the ability to absorb failure without allowing one failure to define the rest of the campaign. Omaha did not end the landing. Kasserine did not end the American Army's development. Hedgerows did not permanently immobilize American armor. A flawed assumption was expensive, but it could be revised. At Kasserine, American formations learned from defeat. At Normandy's beaches, Allied commanders and small units adjusted when parts of the landing plan broke down. In the bocage, tankers, engineers, sergeants, maintenance crews, and generals searched for a way to recover mobility. Culin's cutter is memorable because it gives that process a physical shape. 4 pieces of steel on the front of a tank are easier to picture than a doctrine of organizational adaptability. But the steel only mattered because the organization around it could listen, test, manufacture, distribute, and use it. The Atlantic Wall contained enormous quantities of concrete, steel, mines, bunkers, gun positions, and obstacles. It was a serious defensive system. At Omaha, parts of it worked with horrifying effectiveness, yet its purpose was to stop a landing force long enough for Germany to destroy the invasion. Once the beachhead survived and grew, the value of a fixed obstacle declined rapidly. A bunker cannot redeploy. A minefield cannot chase a breakout. A steel hedgehog left on the beach becomes scrap. The same steel Germany placed on the shoreline as part of a defensive barrier was later cut apart, carried inland, welded to Allied tanks, and used against another kind of barrier. The transformation was not technologically dramatic. No secret laboratory was required. The strategic meaning came from what happened around the metal. Germany had invested steel in a fixed prediction about where and how the enemy had to move. The Americans reused that steel in a device whose purpose was to create new routes when the expected route became dangerous. That does not erase German skill, and it does not turn Allied victory into a story of effortless abundance. German troops fought hard in Normandy. The bocage defense was effective enough to delay the American breakout for weeks. Omaha showed how close a prepared defensive position could come to destroying an assault at the waterline. German armored units could still cause severe losses. Allied bombing could kill Allied troops. American commanders made mistakes. Planning failed to anticipate a terrain problem visible in aerial photographs. Nothing about the campaign was automatic. But by late July, the pattern was becoming difficult to escape. German defenses could impose a cost. Allied capacity could absorb a cost. German terrain advantages could slow movement. Allied units could modify equipment and tactics. German reinforcements could be ordered forward. Allied air power could make the journey slow and dangerous. German commanders could identify the problem. They could not manufacture thousands of aircraft, trucks, fuel loads, replacement crews, and safe roads by issuing a better order. This can be described as industrial mathematics, but only if the phrase is not taken too literally. War is never only arithmetic. Morale, leadership, training, terrain, intelligence, weather, timing, and chance all mattered in Normandy. But arithmetic sets boundaries. An army that loses a tank, it cannot replace faces a different future from an army that loses a tank and receives another. A gun rationed because ammunition cannot reach it fights differently from a gun supported by a deep supply chain. A reserve that must hide from aircraft and move at night cannot respond like a reserve with freedom of the roads. If you want more WW2 history built around overlooked battlefield mechanisms rather than slogans, subscribe and stay with the channel. The German leadership's earlier contempt for American industrial and social capacity therefore mattered because it distorted their estimate of those boundaries. Nazi racial ideology acted as a filter that encouraged leaders to dismiss evidence contradicting their beliefs about the United States. By 1944, the result could no longer be hidden by propaganda. The ships were physically offshore, the aircraft were physically overhead, the trucks and tanks were physically coming ashore. Production figures that had sounded unbelievable were now appearing as military objects on the battlefield. A B-24 contained an extraordinary number of parts and required a huge industrial organization to build. A Liberty ship represented mass production applied to ocean transport. A Sherman embodied standardized armored warfare. The hedgerow cutter was almost the opposite. It was rough steel, shaped with a torch, and welded in a field maintenance system. Yet it reveals the final step that production statistics alone cannot show. Winning industrial war requires more than producing things. It requires being able to change what those things do. A Sherman designed before the invasion had not been built specifically to fight through Norman hedgerows. The army could not send every tank back to a factory and wait for a redesigned model. The problem existed now. So a sergeant and the people around him altered the tank that already existed. Commanders saw the value. Maintenance units multiplied the solution. Then, an offensive used that modified capability alongside artillery, infantry, engineers, and air power. That is the mechanism behind the larger story. By August, the war in France had moved beyond the fields that had trapped the Americans in June. The front that had seemed capable of settling into prolonged attrition had opened. German forces were being forced into retreats and encirclements they could not fully control. The Allied advance would still face serious pauses, supply crises, counterattacks, and costly battles. Normandy did not make the rest of the war easy. It did show that Germany had failed to solve the Central Western problem: how to stop an enemy whose material power kept increasing and whose battlefield system could adapt when that power met an unexpected obstacle. The strongest conclusion is therefore narrower than the claim that one invention won Normandy, but more important than a simple story about numbers. Curtis Culin's cutter did not create Allied air superiority. It did not produce the invasion fleet. It did not plan Operation Cobra, destroy German formations by itself, or replace the infantrymen fighting through the bocage. Its importance was that it connected the smallest level of the war to the largest. A soldier identified a physical problem. Scrap steel provided a workable answer. The command system recognized it. The maintenance system reproduced it. The armored force used it. The logistical system sustained the armored force after it broke through. On June 6th, German defenders confronted the visible scale of that power in ships, aircraft, naval guns, landing craft, troops, and ammunition. In the weeks that followed, they demonstrated that scale could still be frustrated by terrain, skill, and defensive preparation. Then the Allies demonstrated something harder to defend against. They could change. The obstacle Germany had placed on the beach became material for a device that helped defeat an obstacle inland. The same campaign that began with concrete, mines, and steel on the shoreline ended its decisive breakout phase with salvaged steel cutting new paths through the Norman earth. That is why the image of the Rhino cutter deserves to sit beside the image of the invasion fleet. The fleet shows how much the Allies could bring to war. The cutter shows what they could do when what they brought was not enough in its original form. One is scale, the other is adaptation. Normandy required both. Germany could still make the next field deadly. It could still destroy the next tank. It could still delay the next road column. What it increasingly could not do was force the Allied system to remain the same system it had prepared to fight. And once the Allies could produce more, move more, replace more, and alter their methods faster, then Germany could restore the conditions that favored its defense. The question in Normandy stopped being whether German units could win another local fight. It became how long local success could postpone an operational collapse. The answer came not from one weapon, one general, or one factory. It came from the relationship between all of them. Ships crossed the channel because shipyards built them, and naval organizations assembled them. Aircraft dominated the sky because factories produced them, crews flew them, fuel reached them, and bases sustained them. Tanks kept moving because recovery units, mechanics, supply columns, and replacement systems existed behind them, and when the terrain stopped those tanks, a sergeant could look at German steel lying on a beach and see not an obstacle, but raw material. A few weeks earlier, that steel had been part of an attempt to keep the Allies out of Europe. Now it was welded to the front of the machines, carrying them deeper into it.